Okay, so next sensor that we want to interface is LDR, that is light dependent resistor. Now here we are sensing the temperature in degree Celsius. Okay, but sensing the light is a little bit different thing, and there are two ways. We can calculate the lumens, which are not that much accurate. So what I'm going to do, I'm going to just convert whatever input is getting we are getting from the LDR to the percentage. So for that, what I'm going to do simply here, I'm going to type LDR. So there are two options. This is your generic model, and this one is active model. So we are going to take the active model so we can simulate it. Now we have to put it over here. After this, now you have to keep in mind what whenever you are using a sensor. So in that case, you are going to need a pull down resistor. Okay. Now why we need a pull down resistor and what actually pull down resistor means. So let me take a resistor first. We have to just type RES. So we are going to get one generic resistor over here. So we are going to take that, and it should be around 10K. Okay. Now let's see why we need the this pull down resistor first. Suppose let's put this as 3.3. Okay. Suppose this LDR is a switch, simple switch. Let's consider it as a simple switch. Now whenever I'm pressing the switch, so this 3.3 volt signal will be received by this A1, okay, and it will consider it as a high or 1 as an input, okay, high signal or 1 as an input. Whenever I am releasing this button, so the power supply got disconnected, and this port is receiving nothing, okay. So in your coding language, I'll write a little bit over here. In our coding language, your 3.3 volt is equal to high, high signal or 1 as a digital input. Okay. Similarly, if you're keeping the pin open, it doesn't mean it is low. It doesn't mean it is low. So what is low? So your ground signal is equal to low or equal to input 0. So you cannot keep the pin open. It will go in a toggle state. It is going to go in a toggle state or floating state. So for that, what this resistor is going to do, it is going to provide the ground after the switch is released. This one is going to provide the ground or 0 to this PA port. Now what I am doing, I am putting the resistor. Why I am not doing something like this? I am not providing directly ground to this, because whenever you are going to press a switch, VCC is going to follow the least resistant path. It is not going to go towards the controller. It is going to go towards the ground directly. Okay, and if positive and negative are connected directly by the wire, suppose you are having a battery, you are shorting the positive and negative terminal, it will be a short circuit. To limit that, we are putting one 10K resistor over here. Okay, so this is what about the pull down resistor. Okay, now what we have to do simply, now it is going to work as a voltage divider practically over here. Now let's jump to the code. Let's see what changes we have to do there. Let me save this part. Okay, so let's jump to the code. Now in the coding, what we have to do, we have to calculate the percentage. Okay, so for that, what we are going to do, we are going to declare one variable. Okay, so for percentage, let's declare percentage. Let's remove this float. I'm not going to need that. Let's copy this as it is, paste it here. Now what we are going to do, simply UN32 and your light percentage I am going to write for 0. Okay, now we have to do the calculations. So for that, we are not going to need this millivolt and all that stuff. So we will keep it as it is. We are not going to need that millivolt or voltage. Here what we are going to do, we are going to need ADC value. Now, practically, how this formula is like, okay, it is like how you calculate the percentage of your exam marks. So, in similar way, so ADC is the marks you have got, okay, divided by maximum marks. So, ADC is number of steps, and this one is maximum steps. Okay, this is how you find your examination percentage, and after that what you used to multiply it by with the 100. Okay, yes, you're going to multiply it by 100. Yes, so just for sake of typecasting, okay, we don't want to get these values in the floor. So what I'm going to do, I'm going to first multiply whatever we are having with the 100, then I'm going to perform the division. Okay, one and the same thing, 4095, and this is where we are going to store this part in the light percentage. Here we are going to mention light. Let's mention light here. Whenever you are using LCD, try to use capital letters. It looks very good and professional. And here instead of LF, we are going to, so 1F, we are going to use long and sign. And here we are going to use the percentage symbol. And done. Let's build this. What is the warning? So we are not using the millivolt, no problem. So we are going to ignore this. We have declared this voltage and all that, but we are not using this, so that's why we got the warning. Now what to do further? Simply, let's go to the Proteus. Let's run this. Okay, so it is showing one. Let's take a torch closer to this. So as we are pushing our torch closer to the LDR, its resistance is going to decrease. Okay. Now, if you are going to purchase a resistor, you have to tell the value of the resistor, 1K, 2K, 3.3K. LDR comes in 10K value. Okay, 10K, when it is going to provide you 10K resistance, when it is in complete dark. Okay, means at this point, let me remove the torch. At this point it is almost providing the 10K resistor, so zero current is flowing. This one is due to leakage current. There will be a little bit of leakage current, and when you are taking it close towards your LDR sensor, so it is going to provide you the light values over here. Let me see why we are not getting the percentage symbol here. Okay, percentage is having the special meaning. So let me try this. Let's stop the simulation. Okay, your percentage is having a special meaning for percent and all that. So that's why it is not getting displayed. Let me check once. Mm, change the format. Okay, let me see whether it is going to work or not. Okay, let me see what else we can do the change. So let's jump to the code. Okay, so this is not going to work. Let's put percentage symbol over here to skip this percent. So first percent is having the special meaning, so it is going to get ignored, and our second percent is going to get displayed. Let's compile this. Okay, we are having one warning, that is for voltage variable. Let's run this over here. Okay, so we are getting the percentage symbol as well. So this is how you can simply interface the LDR. So in next session we are going to perform same on the hardware.